I'm here to talk about connected services for vehicles of tomorrow, with a subtitle of Information of Things by Combitech. So who are we? We are about 1,500 consultants working with technology, environment and security. We are fully owned by the security and defense company Saab. So, for example, I work across the street at Saab Kockums at the moment. We are trying to build 2 submarines for the Swedish Navy. And the purpose of this talk is to let you know something more about the vehicle industry and what's happening with this connected car thing. And I also want to inspire you about working with open source. Not only open source software, but also hardware, actually. And if I'm going to speak for 40 minutes, I need to have some kind of agenda, otherwise I will lose track. So the points that I will go through is a point about reinventing the vehicle infotainment. So we will go through what vehicle infotainment is all about and what's happening in that domain. Then we'll talk about this information of things. So this is basically the what thing, and then we come to how you can do this, building such a system with vehicle infotainments and information on things. And we'll talk a lot about adopting and adapting, not reinventing the wheel. And then finally, I hope to talk about innovation and how that actually can help you in doing things, inspire you. Does that sound fair to everyone? So, vehicle infotainment, what is that all about? So, traditionally, in the cars that, or at least the car I had when I bought a car for the first time, 1990, is the kind of FM radio that you have, listening to maybe AM radio as well. Then it was expanded with DVD. And after that, we could actually connect your Bluetooth phone, enabled phone, to get your phone call through the to the car. And then it's been expanded with GPS for positioning services and so forth. And what happens then, if you look at aspects like safety and quality and environment, what are those aspects about, and how can they help you or actually be a hindrance for you with some challenges? So this is a funny picture. I mean, that's maybe how it looks in some of your cars, but this is actually also reality if you look in a truck of today. So is this safe? So this is a driver that drives something from A to B, but this is also an office. It's unbelievable what they put into their driving cabins. You have your laptop, you can read mail or watch movies, I don't know what they're doing. And then you have all kind of communication systems and tactometers and so on. So this is definitely a challenge. And this is why the infotainment business developers within, for example, Volvo, have started to look at how can we make this environment safe? How can we build a service platform where we can enable all these kind of services that obviously the truck driver wants, but do it in a safe way and maybe cut some costs at the same time. The other aspect is about quality and environment. Because if you have this kind of service platform with one or at least a fewer number of devices than the picture before here, you can actually build different kind of services. One of the services that you could do is around quality, having uptime of your truck, having preventive maintenance, so that you actually, before something breaks in the truck, you can change it. You can also look at the environment aspects, having the economical driving. You can actually get information about how should I drive this truck in an economical way on this specific route. You can also have this kind of routing in case of traffic accidents and so forth. So this is what the vehicle industry is looking for when they talk about reinventing the infotainment system. Not only looking at the kind of traditional services, but actually having it as a platform for providing services. Another aspect of quality is actually the possibility to push out new services in a fast way. Not only looking at the hardware aspect, but also software aspects. So I think this gives a background on why we are looking into the vehicle industry when we talk about connected things. So now I'll move over to something that we call information of things. And I think you're all familiar with this concept, the Internet of Things, everything that talks. So Gartner actually have a definition of it. It's this network of physical objects that can communicate with the kind of internal states of the object and communicate with everything around it. And that's grand, because that's really something that is happening today. But you can look at also it from different perspective in two different technologies that is happening today. One is the information technology that is moving into the cloud, with companies like Microsoft and Amazon providing services today where storing and moving data is almost for free. And you have services like Hadoop, where you can actually then process this data to get some kind of information out of it. So that's one very important aspect in this. The other thing is embedded things that actually talk. I mean, it's impressive today with 5G and 4G technology, where you have coverage all over the place, on one hand. On the other hand, you have this kind of passive radio technologies with NFC, for example. You don't even need to have a radio to communicate with certain devices. So if you combine those two technologies, the information technology in the cloud and the embedded things that can talk, you get something really, really important. You get information about things. And that can bring value to your business. So value is not really created when you connect things. Value is created when you can use that information for your business. So, I want to give you an example. This is a product. It's called CB. It's produced by a Swedish company called Clean Motion. It's a 3-seated moped. It weighs about 300 kilos. It travels at 50 kilometers per hour. And it can travel for 50 kilometers without recharging. So basically going from the turning torso to the Ideon torso in one charge. And it uses about 4 kilowatt hours per 100 kilometers. So figure out the cost for driving this around. And what is really neat is that you don't need a driver license. You can be 15 years old with a moped license. So my daughter at home used to drive this around in our village, and that was really popular. So it's quite nice. It actually has a compartment thing here where you can store stuff as well. But it's not smart. So what do I mean with smart? Well, it has this traditional analog interface that shows you speed and the amount of charging that you have left. But you cannot personalize it, meaning that when I go in, I have my places. I can adjust the layout of this one. And it's not connected. But when you do this, if you get it kind of smart and neat, personalized, and you connect it, then you have a smart connected product that you can put into a context. And that context can provide you a smart connected product system. So for example, you can then enable services like rental, maintenance, or you can find the closest charging station. So now we have a smart and connected product in a product system. Now you can look actually at other systems around you. So, as an example, if I have a convenience store and I want to attract my premium customers, offering them free charging while they're in my store, or send them special offers, or if I am a fleet manager having delivery services, I can use this product now to provide logistics and an efficient delivery of items. So again, we have a product at the center, but with some quite easy extensions. You can provide completely new services and business opportunities for the company here. And if we expand this is a concept car that we at Combatech are using to test new solutions and so on. But if you take this picture and move into some real business, like the truck, then you can see how you can actually transform value out of a truck into having it smart. You can connect it, you can create your product system with fleet owners and aftermarket and body manufacturers and so on, into a complete system. And as an example here, you can have waste management and see how you can actually effectively that one with connecting it to traffic systems, production system, sensor fusions, creating completely new possibilities. And what's actually happening here is that you're adding, should we say, different data perspectives. You're growing the kind of information available about the product and its surrounding. So again, information about this is something that creates value. This is a big discussion in US about information, because it's about who owns the data. Is it the manufacturer? Is it me as an owner? Or is it the fleet manager? Or is it the infrastructure? Because looking at this in a kind of infrastructure way, it would be really good if the Trafikverket in Sweden could access this kind of data. For example, when my ABS kicks in, or the what do you call it? The anti-sladd system. If that information is traveled up into the system, you can communicate that to cars going on that road in the next couple of minutes to get warnings about traffic situations. So there are different stakeholders of this data, and in US this is a lively debate about who actually owns the data. And we had a conversation here in the pause about who owns my data that I have in my mobile phone or in my laptop, because data has value, especially when you propagate it and compare it, running your Haskell programs or whatever to actually show value out of data. So one aspect, though, that is really important, I show how we can create value from connected systems. That is what happens when you're not connected. And I really like this comparison to the escalator. So what happens with an escalator when it breaks down? It becomes stairs. So it still has the same function, transporting persons from A to B. But it's this kind of graceful degradation. So you should really think about when you create your systems, use the fact that it's connected, but don't make it dependable that it's connected. So that was about what you can do. Oops, sorry about that. So we have looked at the vehicle infotainment part, what's happening in the vehicle industry. We have looked at the possibilities of actually getting information out from products. Now we will go into and look at how you can create such a system that I showed. And the lead word here is adopt and adapt. Do not reinvent things. It's very seldom that you actually invent new things, unfortunately maybe, but there are other ways of innovating. We will come back to that as well. So we will go through how you can adopt and adapt solutions within the vehicle part, and also in the more cloud and information technology part. So the challenge that I was put against about 2 years ago, we had a discussion with Volvo Trucks in Gothenburg. They wanted to create this kind of service platform that we discussed and put it in their trucks. The problem was that there were so many different solutions and communities around. So we did a study and trying to analyze the different auto alliances and the communities available. So it's like, okay, there are quite many. So if we start down here in the left corner, we have solutions that provide a certain functionality that is called MirrorLink, Android Auto, and Apple CarPlay. That's solutions that allow you, when you take your mobile device into a car, it can display your phone in your car. So basically it mirrors. This is the proprietary way with Android or Apple then, and then you have the non-proprietary way with MirrorLink. And that was not really interesting for Volvo because it's about the service platform and creating services in the truck, whatever phone you have and whatever you have installed. So they went away. Then we looked at Microsoft Windows Automotive. That's a platform that actually exists today. It's very common within manufacturers like Volvo Cars. But it's proprietary, and there is license issues with it if you really want to use it in your way. So that went away, and also the QNX, the former BlackBerry operating system. It's the same license issue, unfortunately. So we are left with, of course, Linux as a platform, and there are quite a lot of initiatives based on Linux within the car industry. There are things like Geneva, Tyson, automotive-grade Linux initiatives. Unfortunately, they all focus from bottom up. They focus on technology, trying to solve boot up times, because when you start a car and you have a camera in the back, you need to see the camera in 2 seconds, and all these kind of requirements. And having worked with Bluetooth standardization for 8 years, actually, looking how they took a great technology and enabled it in a lot of devices by doing use cases, something called profiles, that actually explains how do you use the different protocols and capabilities of the Bluetooth radio. So inspired by that went away, because unfortunately those groups look at the kind of usage of the system, this service platform, from the bottom up, from a technology perspective. That left us with 2 things. One being AutoSAR, that is a commonly used operating system for cars, but it's focused on device-to-device communication. So in the car you have a lot of different buses. The most common is the CAN bus, and this provides a operating system or a component architecture that lets your devices talk with each other on the buses. So that went away as well. Now we have 2 left. The Android open source project. Is everybody familiar with that? I guess most of you have heard about Android at least. And then it's the Android open source project. And then we have the World Wide Web Consortium that is focusing a lot of HTML5 and web services. So the great thing about the Android open source project is it's for free, and it's a really nice service platform. You can do a lot of nice features on a mobile phone, but you cannot use it in a vehicle. You cannot read out data, for example, from a vehicle with it. But you can use it, and you can add whatever functionality you want, and you can push it out and have users using it in any way they want, on any devices they want. So we catch this one, and we looked at it also for another reason, because it's a fantastic platform if you want to do web services. The problem was that we didn't have a driver for doing this. So we find one that is called Vehicle ICT in Sweden, that is situated in Gothenburg. So we started a small cooperation led by Volvo then to create this kind of open platform for automotive, completely free. The work was started in March 2014, and we got 4 months 4 guys to put up a proof of concept and actually get this out in a community kind of way. So how do you do that? How do you create your new automotive community? Because if we just look back at the things that I have had up in the left, the Genevi and the Tyson and the automotive grade Linux, that's major players here. The communities are really large. There are hundreds of people and they've been working for many, many years. Now we were 4 guys that were supposed to work for 4 months. So what do you create then? How can you create anything? Well, to start off, Android is a quite good platform, but we realized that we at least needed a collaboration platform where we can actually tell people what we were all about, designing and developing and distributing a automotive platform. You need to have some kind of continuous integration because we were going to produce code and we wanted it to continuously integrate. And we need to provide some kind of repo to have downloads. Then we had a pre-hack just before the summer of 2014 where we demonstrated this and invited a number of programmers to use it. And then we got instant feedback that we really need a simulator for this. We had provided some simple simulator, but we need something like a car simulator where you can actually be driving and read data from this car simulator. So this is an open source initiative, Torx, the open race car simulator. So it's for free. You can download it and you can adjust it as you want. What you couldn't do is to redistribute it because it's GPL. But we were allowed to change the name, so we actually changed it to another name than Course, the Combitech Open Race Car Simulator. So we had our automotive grade simulator, simulating a car basically, that if you have a car simulator, it can read speed and so forth. And then it can send it to this kind of infotainment system. So that's what we produced actually. And up to date, we have had 80,000 unique visitors to this. We have had almost 10,000 downloads of the SDK. And yeah, that's amazing. I'm not sure where they're going into, what kind of stuff. But that's also another important aspect that, yes, this is how you can integrate it into a car. But actually, you can integrate this into a submarine or integrate it into a bus or whatever other technical. So we're basically just showing how you can use Android as a platform to integrate new services. So the next slide I will show you the thinking that we had around Android. So this, you need to imagine, this is 1.5 years ago. So it's the old Android with the Dalvik. Today we have the art. But basically, you have the kernel, you have the libraries and the runtime, you have the application framework, and you have the applications. So we wanted to create something that is quite similar to how you interface a radio in Android. Radio meaning the telephony radio then. So we looked at how that solution was created. You had your application, you had a telephony manager, you had a radio interface layer daemon, and then you had the library that actually talked to whatever physical interface you have to your modem. So inspired by that, we just did copy-paste, basically. It's open code, right? So we created the same solution, but with a automotive manager. And with one other aspect that is really important. It's important in Android phones, but it's super important in a car. And that is you really need to have a certificate because you need to have some kind of policy implementation. What applications should be able to read what data from the car? Or should it even be able to write data to the car? I mean, one use case is that is really nice. I don't know if you've noticed it, but when you're out driving in the city, I think 9 out of 10 blinkers, signal lights, are broken. How can that be? That's really irritating, I think, especially in roundabouts with all different kind of rules. wouldn't it be really nice if you had this kind of guiding service? I'm going from A to B, please guide me. And when I'm guided, the signal starts to blink to right or left or whatever. I don't need to think about it. I mean, that's just one simple thing. Another thing that you could have an application to steer your heating in your seat or the fans or air condition or whatever. So you would absolutely want to write something to the vehicle as well. So certificates, the OEM hands out so that you can shows the policy, what can the application reach and what can it not. We also provide some basic signals that the vehicle industry has agreed that you can actually access. Maybe you have heard about the OBD2 protocols or standard. When you go into maintenance of your car, they hook up with an interface and they can read out some data. So all those signals that you can read out from that is implemented today. And then, of course, every OEM will have their own proprietary signals that they want to provide. So that's the basic. You have some kind of policy on what you can access. You have a predefined set of signals that you can access. You have some kind of proprietary, business important things that you can access. Some signals from the bus you actually want to integrate into the Android system itself, like the hardware buttons for home and the volume up and down. You don't want that to go to the applications. That goes into the ordinary Android system. And you also want to have some kind of driver distraction function. So if you are in an actual driver distraction situation, you get broadcast to the applications to dim the screen or exit or whatever. But that's the basic. So you have the application interface for the application developer. You actually just see an automotive service. You have the OEM that needs to integrate this solution in whatever way he wants, because there are many different possibilities to integrate here. You can integrate directly to the CAN, you can do it via SPI or Ethernet and so on. But that's how it looks. So this is the actual SDK that we provide, besides the collaboration platform and the continuous integration and the download parts. This is the actual SDK, and then we have some example implementations for this one and how you actually integrate. So to date, the companies that I do know about is Volvo Trucks, Volvo Buses, and the Volvo Construction Equipment are today basing their infotainment systems on this platform and building services on it. And that is really exciting. So that was about the vehicle part, how you can do a vehicle infotainment with 4 guys in 4 months. And we have an active community where we're actually adding functionality. But we should also look at the other side, the cloud. What should you choose from there? Because there we really have a lot of possibilities with technologies and solutions and communities, and it's amazing how you can do things in different ways. And it also makes it harder. How do I actually decide? What should I use? What should I base it on? So our thought here was, so we don't spend time on analyzing. We pick one, and then we build a system for it. And we had looked previously on something called microservice architecture. Are you familiar with that? It's a really nice concept of dividing services in a distributed way. So we created this system. So if we start from the left, we have this CB. We also have the simulator. And this I already showed, how you can connect to an Android open source platform where you can have your implementation. So the green here is what we actually implemented. The bluish is open source components. So what we actually did, we ripped out the analog thing, and we put in an Arduino that was able to communicate with the CAN bus with an add-on. And we connected the SPI of the Arduino to the Android tablet in this case. and implemented this kind of lower levels of the automotive grade Android system. So we could display things for the user, and we could also grab data and transport it to a service bus that is based on MQTT. So we picked Mosquito. So basically it's a publish subscribe thing. So you can publish things and then you can listen to messages or subscribe to topics, as it's called. And then you can both subscribe and publish from one of those nodes. So basically what happens is that we publish a lot of data from the car. We do it regularly on an interval, and then instantly when things change in the car. And then we have a number of services that will subscribe on these. So we have a database service that subscribes to everything and puts it in a database. So this is a MongoDB, also open source then. And then we have implemented some services here. Predict distance service. It showed that when you're out driving with this, it could say that you have 40 kilometers left, but because of the temperature and maybe the way I'm driving, all of a sudden it could be 20 kilometers without me going 20 kilometers. So this thing here tries to predict how far you can actually go depending on a number of variables that is published by the car. We have a point of no return service that basically it provides a home address for this guy, and if it sees that the predicted distance service is further than the distance that you have to your home address, it will signal and give you a warning that if you don't have a friend nearby, you should start going back now. We have a low battery service that basically just warns you if you're really low on battery and you're driving in an aggressive way. It tells you to please think twice before you go in 45 kilometers. You should probably slow down if you want to reach the home position or wherever you're going. And then we have geofence services that is both fencing where you should not go and tells you when you have reached the target. So for example, if you're a fleet manager or you're renting these vehicles, you can geofence, saying that you are not allowed to go out of the inner cities of Malmö with 10 kilometers, for example. So these are really simple services, and the guys that implemented it, they could choose their own favorite language. So some have chosen Python and Java. We actually implemented a backend service in C#. So it doesn't show here where it's instantiated. Basically, this here is instantiated on AWS, while this is running on Azure cloud. So you have the possibility to instantiate wherever you want and pick whatever programming language that makes sense. And then we have the front end, of course. We'll come back to that in the next couple of slides also. It's really important, like here, to show the user. You want to have a user here. We base it on the open source framework Angular from Google. And then we actually used a proprietary component or framework, DevExtreme, to create the graphical parts. But you can create quite some nice functions in a quite easy way. So this was actually realized when we had done this initial architecture. We had 2 students from LTH this summer. They were with us for 8 weeks, and they implemented the complete solution, integrated and tested everything. That was very impressive, I think. And it also showed that we had a concept that we could move forward with, creating real IoT platforms. And this is open source. So yes, this is open source, but this is actually also open source. So we put everything on GitHub for anyone to pick up and use if they want to. And this would not be possible unless we had this open source initiative, the PAHO project, because this was what made it possible for all these kind of clients that we built the Android device, the C# parts, the front end, and the microservices, and the database service. They're all based on that. Paho provides MQTT client implementations for Java, Android, Python, JavaScript clients, and so forth. And that's really nice. Okay, that's a very good question. So MQTT, by definition, is unsafe. It has this concept of user and password. That's really unsafe. And in this implementation, it's unsafe. But when you do instantiate it in a real kind of product, you use TLS. You have other security mechanisms. So you're absolutely right. It's very unsafe. The only safety is around that you can set the broker to accept only certain IP ranges. That's kind of security by obscurity. So that's. So remember my always connected and the escalator? Yes. Yeah, exactly. So you need to take care of that. So that's why you should not only depend on this or this. You really need to use the data that you have here. So you can still show the kind of speed and if you don't get the values here on the distance, you read it from the car. So that's a good question. But again, think about not always connected. When you're connected, you have some great services. That's also actually a discussion we had. That's a really good question. The concept here is that we don't put any services here. So this is kind of dumb. And the reason why you put it here is that you can charge for it. And you have full control with the software updates and so on. But there were a lot of concept discussions when we created this architecture. So it's a good question. But again, I think really Paho, that's a good project. Yeah. So architecture and things, but what you as a user see is only this. That's the UI. So this is the UI of the vehicle, the CB. This is the UI of the portal, the Angular web service. And that's, for me, as a original programmer hacking C in exchanges and in mobile devices, it's really important that you think about the user and who is going to use it. Because again, just connecting things and sending data, it doesn't provide any value. So you really need to think, how do you create a user interface that can benefit from all these services without getting it really dangerous to look at your screen? So we had to think a lot about what buttons do you have and how do you dim them so that it doesn't take the kind of control out of the driver. Because we have some kind of mission services. I didn't show that. It's recently implemented. So you can send a mission to the guy here and say that I want you to go to this place and collect this package. And then it shows up as a message here. And then when you press it, you will get a map up. And it will give you driving directions. When you have driven to the address, you will send a signal to this part saying that I'm here and I've done whatever was supposed to do. So that is really kind of safety and usefulness design. This is more about the different users that you have, because there are so many different users of this interface. You have the manufacturer, you have the owner, you have maybe the driver that want to access this as well to get some data out. So you need to think about it, and it's really fun to work with these kind of use cases and user scenarios. Okay, so lastly, I just want to inspire you on open innovation. So we talked about what, how, and now we can look at how can you actually use this openness to create innovation, real innovation. So what we did, creating this automotive-grade Android platform, we had contact with Chalmers in Gothenburg. They created a course for 200 students with groups of 3, with a challenge of you have an 8-week project, create services based on this. And it was impressive to see what they were able to create in 8 weeks. It was really stunning. And then you really realize that you're old and slow thinking. Yeah, because they really thought about services and how can we use this? And yeah, it was really impressive. And what was even more impressive was the way Volvo handled this, because they set up a competition. So they had the three best teams. They won some prizes, and they were allowed to enter a open innovation challenge arranged by Volvo Trucks this spring, where they invited professional companies like Combitech and those three teams from Chalmers, students, and challenge, okay, who can come up with the best idea during 2 days of hackathon? The students didn't win. They come on third place. Because the winners were, it was outstanding. It was this combining different solutions and services. Because that was an idea from Volvo. How can we get other industries into the vehicle industry, helping us out, creating new innovative services? So that was a big success. The winner attended the Volvo Ocean Race and the boat that Volvo has. So they were quite happy. But again, open innovation, this is how you do it. You create something, you publish it, and then you make sure that people use it. So now Volvo this course has been going on for 1 semester. So now they have 400 engineers that can use the Android platform for automotive. That's smart. Okay, you've heard about reinventing vehicle infotainment, information of things, adopting and adapting, and open innovation. So I hope I have inspired you and made you think about also business and not only technology, and how you can actually create, not business only, it's actually added value for the end user. Thank you.